Hello, I'm Meng Du. It's an overview of our project, and let me introduce the step 1 to step 4. For the step 1, we are going to do the autocomplete. We first use the transfer function to transfer the input into lowercase to make it case insensitive. Then we iterate each node to check if there are some nodes that can match with the input. And the time complexity is On. And for the step 2, we need to find the position. We iterate all nodes to find the position, then return the latitude and the longitude of the position. And to calculate the edit distance, we use dynamic programming, and the running time complexity is OMN. To calculate the edit distance is just to calculate the minimum number of operations to convert string A to string B. And let's define Dij to be the edit distance between the ith character of string A and the jth character of string B. It turns out that one could compute Dij knowing these three states. There are several situations when the ith character of string A equals to string B, then the Dij just equals to Di minus 1 J minus 1. When the ith character of string A doesn't equals to the j's character of string B, it will have the three situations below, and we need to plus 1. And when the edit distance is 1, we can find a closest name, and it is the screenshot of this function. And for the step 3, to get all variable categories without duplicates, we can iterate all items and put them into a set. And then we can put all items from the set into a vector and return the result. And for the step 4, we can get all locations in the categories. We use getting all categories function to get a vector with all categories without duplicates. Then we iterate all items in that vector to find if it matches with the input. If not, it will return this result. Else, we can iterate all items of the data and return those with the same categories as the input.
Okay, from the step 5, I will introduce the step 5 to step 8 because the step 9 and 10 are not completed yet. The step 6 is to calculate the shortest path between two places. And here we can input the source node and destination node, and the result is here. And from this graph, you can see that the running time for the texture is much more quickly than the running time of Bellman 4. But texture can handle the negative cycle and negative edges. But for Bellman 4, it can handle negative edges, but still cannot handle the negative cycles, and it can only report a negative cycle. And here's the output of the shortest path. For step 7, it is the cycle detection. First, we need to input 2 longitude and 2 latitudes to get a graph on the map. And here's an example with a cycle. And here's the output. And here's the example without cycle. And step 8 is topological sort. In the topological sort, we are using the algorithm that is quite similar to that is used in cycle detection, that goes DFS. But for the topological sort, we are handling the directed graph. That's the only difference. While in the cycle detection, we are handling the undirected graph. And here we need to input the names and the dependence for each node. And when we are running the DFS, we can get a topological sort like this. And that's all. Thank you.